Hello everyone, welcome back to MGF1106. In order to understand probability better, we need another concept called combination. So last in the previous video, we already talked about the counting principle and permutation concept. Now in this video, we'll be discussing a combination concept and see what's the difference between combination and permutation. Okay, so let's get started. So I'm going to put here combination. Okay, combination. Okay. So on the first part again, let's talk about definition. What does combination mean? Definition combination. So combination is a distinct group of object or a distinct group of element. A distinct group of object. Okay, distinct group of object without regarding to their arrangement. Without arrangement. It means what? It means that we don't have to worry too much about. We don't have to worry about order. So no need order. Okay, no needs order. So the difference between permutation and combination is in the permutation, order is important. Okay, order is important, but for the combination, order is not a matter. Okay, so we have a group of n object and we want to collect r object, a group of r object out of n object, and we don't care about order, no arrangement. Okay, so that's the difference between combination and permutation. And the formula to find combination is C. C represent combination, n sub r is equal to. Okay, let me use different color. Okay, so we have n element and we have r element over here. We find combination r out of n, so it will be n factorial over n minus r factorial. Okay, divided by r factorial. Okay, and because they be divided by r factorial, so you see that maybe compare between permutation and combination, you see combination will be less option, right? Will be less possibility, less combination. Okay, so permutation will has more option. Okay, we have more option, but combination you don't have more option over here. Well, you can calculate a permutation. For example, you can calculate. Let's say I can calculate a C of 3 1. So it will be 3 factorial over 2 factorial. Okay, and 1 factorial. Okay, which is this is give you 3 times 2 times 1, and this is give you 2 times 1. Okay, so it's only 3. Now you compare combination with permutation, you will see what if you have 3 3 1 over here, then you have 3 factorial over 2 factorial. Oh, in this case look like it's the same because this is 1. Maybe change a little bit. Maybe we need to change a little bit here. What do we have? 2 factorial of 2 over here. So you're gonna have 2 times 1 over here. Okay, so at the end, 3 minus 2. Maybe I need to change another number so that you can see, so that you can it's easier for you to compare. How about if I change this to 5? Okay. Okay, let's see which one is bigger. Okay, so we're gonna end up with 5 factorial. Okay, 5 factorial. Then 5 minus 2, 3 factorial, and 2 factorial. So you can have 5 times 4. Then over here you have 2 times 1 factorial, and 3 times 2 times 1. Okay, then you're gonna end up with what? You're gonna end up with 5 times cancel this. So you're gonna have with 20. 20 divided by 20 divided by 2, which is give you only 10 possibility. Okay, how about this? So we have 5 2. So again, you're gonna have 5 factorial. Okay, and 3 factorial. Okay, we go 5 minus 2, 3 factorial. So you're gonna have with 5 times 4 times 3, and 3 times 2 times 1. So in this case, you're gonna end up with see something 3 5 times 4 times 3 times 2 times 1. Okay, so you can see that it's gonna end up with like 20 options. So you see that permutation is has more possibility, has more option. Okay, but combination is not, because we consider the order into permutation, but combination there's no order, so that's why it has less option. Okay, let's check one more time. Okay, all right. Now let's jump to the example right away, and we deal with the application. I guess because over here we don't have the first Roman, so I'll just go ahead and delete this because we don't have the second part. So this lecture is not as long as the last one, so I'll just go ahead and delete this. Okay. Okay. Now let me jump to the example number 2. Okay, in this example number 2 here, we're gonna deal with word problem. Okay, so right here. Okay. Okay. Now let's read the problem. Let's see how we do this one. Okay. Answer. Okay, so I have we do want to determine this is a permutation or combination. Okay, first of all, we're dealing with the combination right now, so of course the problem will be combination. But you see that when you read the problem, they didn't say anything about order or arrangement. So this one it will be combination definitely. How many ways you can select 3 songs from a list of 200? So they didn't say that which song go first. They didn't say that we have to stack all the song, or we have to download which one first. So of course no order needed over here. So part A we can solve easily by using combination formula. So we have 200 download. So we pick only 6 from 200 download. So you're gonna add with 200 factorial. 200 minus 6 factorial, and 6 factorial. Now we're gonna go ahead and use calculator here to solve the problem. I'm looking for my calculator right now, and okay, it's right here. So we go ahead and put it into the calculator. So let's see. Okay, so you have let's say 200. Okay, math and 6. I don't know how we're gonna put this. Mm, this is pretty big number right here, guys. Um, because over here is 200 factorial. That's a pretty big number. So if you put it into the calculator, you see that it gives you big number. I cannot even write it over here. But that is the way you set up the problem. You don't need to get the answer because even the calculator is have hard time to list the answer right here. But you know this is the way you set up. Um, in a race which is 50 runners, no time, in how many way can the first three finish come in? Okay, so you see that when you have a race, of course, uh, you will see which one finish the race first, right? And you will have the first one finish the race, the second one finish in the race, and the third one finish the race. So it looks like they have order over there. So that's why this one is to be computation, and this is what you're gonna do. 53. Okay. Okay, this one I'm sure we can do that. Hopefully with calculator. Uh, okay, this one give you 1176 zeros the option. Okay. Yeah. Pretty easy, huh? Really easy. Not really that bad. Example number 3. Okay. Now, what if we have this one? Okay. So you volunteered to purchase for your friend who's been 7 different animals. How many different pet combinations are possible if you take 3 out of 7? I see that if you just take 3 out of 7, we don't need to put those pets in order. Which one go first, which one go second. So of course this problem very easy. We just pick 3 out of 7. So you have 7C3. We have factorial 7 factorial. Then you have 7 minus 3 factorial. Then you have 3 factorial. Okay, put into the calculator, you have 7. Okay, and you have 3. And you're gonna have with only 35. Okay, so there are 35 combinations. There's 35 options to pick 3 out of 7. Okay. Example number 4. Okay. See, not bad, huh? Okay. Okay. Okay, so for this example number 4 here, how many different 4-card hands can be dealt from a deck that has 16 different cards? Okay, again, they don't say anything about order. Okay, they didn't say anything about order. They just ask you to pick 4 cards from 16 cards. Right, 4 card handed from 16 cards, so you have 16 4. Okay, you put it into the calculator. Okay, and you have 1820. Okay, different way. So there are totally 1820 different way to pick 4 cards out of 16 cards. Okay, example 5. Easy. Okay, how about this? Okay. So you have a zoo and a 6 male bear and a 7 female bear, 2 male bear and 3 male bear will be selected. for animal exchange. How many fiber collection? Okay. Okay, so this problem is a little bit harder. You will see that totally we have 6 male bear. Okay, and 7 female. Okay, now we're gonna pick 2 out of 6. So we're gonna do pick 2 out of 6. So we do C6 2. Then we're gonna pick how many? 2 out of 6. Oh, 2 out of 6 and 3 out of 7. Okay, so we're 3 out of 7. Okay, this is for male, right? 2, and this is for female. This is male with female. Okay, so C6 2. Okay, which is give you 15 option to pick male, to pick 2 male, and 7. So that will be 35 option to pick 3 female. So this is mean 15 option to pick 2 male, 35 option to pick 3 female. But we need what? We need a group of 2 male and 5 male. Let's see how many ways to pick to create that group. Okay, so in order, this is where we're gonna apply the counting principle. So there are 15 ways to pick 2 male, 35 ways to pick 2 female. Then in order to create a group of 2 male and 3 female, we're gonna go ahead multiply each other. So we're gonna multiply 15 by 35. So there are 525 way to pick a group of 2 male and 3 female bear. Okay, so the group over here make it like totally 5 bear. Okay, good. Now next example number 6. Let's see. Okay, answer. So we have a restaurant. So we have 3 columns. So we want column A. We have column A with 3 items. We have column B. I'm doing a summary right here with 4 items. And we have column C, 3 items. Alright, if a column A, B, C have 5, 7, and 6, so the total we have for column A is 5 items. The whole thing is 5 items, but we want to pick 3, and we have 7 items. We want to pick 4, and we have 6 items. We want to pick 3. So we pick 3 out of 5. So in order to create a different linear combination, we're gonna do C5 3 here, C7 4, and C6 3. So the total, in order to get the total, you're gonna go ahead and multiply this. So we have number way of picking from column A. Then we have a number way to pick from column B. We have number way to pick from column C. If you multiply them up, then we have the total number of methods to pick from column A, B, and C. Okay, so over here we're gonna do calculation. We're gonna in the example 5 and 6 over here. We applied a combination concept, and at the end, in order to get the final answer, we have to use the counting principle a little bit. Okay, so we have 10 over here, multiplied by 7. We have 35 here, and you multiply by 6. 3, and we have 20. So you multiply them up, so we have 35 times 10. So we have 7,000 options. Okay, 7,000 possible linear combination. That's what it means. 7,000 possible linear combination. Okay, good. All right. So after we learn the concept of permutation, combination, and the counting principle, we're going to go ahead and start the concept of probability. Okay, in the next video. Okay. All right. Please go ahead and watch this video carefully. If you have any questions, let me know. I'll see you next time.